All right, let's go ahead and jump into section 2.5. On section 2.5, it says below is a set of lines cut by a transversal. Using what we learned in the previous lesson, explain three things you know about specific angle pairs in the diagram. So one of the students said that 1 and 4 must be congruent because they are vertical angles. Another student said 1 and 2 had to be supplementary because linear pairs are supplementary. Some kids said that 6 and 7 had to be congruent because of vertical angles theorem. So basically what we are having here is a lot of students remembered that if two lines intersect, you end up with congruent vertical angles and you end up with supplementary linear pairs. Now, the thing with this is that that was specific to a single intersection. None of them were able to actually tell me something that was true about angles from one intersection and how they related to angles of another intersection because we hadn't learned about that yet. What the students then did was they measured all of these angles. So they measured the first one and it was 67 degrees, then they had 113 and 113 and 67, and they measured all these angles looking for some kind of a pattern. What they found was that all the angles for one of the intersections seemed to match up with all the angles in the other intersection. Now, that was not true on the intersection down at the bottom where line 4 intersected line 3. Those were all different random angles. So they ran through these questions in class. Number 2 was them measuring all the angles. Number 3 says, we know that there's a relationship between angles with a single intersection, but what about different intersections? So on here, we found out that there was a relationship between the angles at different intersections. And at these different intersections, it seemed like they were either supplementary or congruent, just like what we saw in the last lesson. Now, the next question was, what is special about the lines that intercepted line 4 in the locations where there appeared to be a relationship between the angles? So that was, how did line 1 and line 2 compare? Because they were the ones that had the intersection where the angles seemed to have some kind of relationship. And what students were able to pick up on was that those lines were parallel. So there must be something true about parallel lines intersected by a transversal versus non-parallel lines that are intersected by a transversal. So before we formalize that, we had to name all the different types of angles. Now, mathematicians like to make their names pretty easy when you're talking about naming something like, oh, we have something that bisects an angle. What should it be called? Let's call it an angle bisector. We have two things, which we call a pair, and they are linear. What should we call them? A linear pair. So on here, when you look at two lines, and they don't have to be parallel to have these names, but if you have two lines and they're intersected by a transversal, you could have these angles, which I labeled 1, 2, 3, 4, 5, 6, and 7, and 8. And there's going to be an interior between the two lines, and there's going to be an exterior outside of those lines. Now, the other thing is the angles are either going to be alternating sides or they're going to be on the same side. So on here, you can see that angles such as 3 and 6, 3 and 6 are on the interior and they're alternating. So we call those alternate interior angles. 4 and 5 are alternating sides and on the interior. So we would call those alternate interior angles. So those are both examples of alternate interior angles. We then looked at 3 and 5 and 4 and 6, and they were on the interior and they were on the same side. So that was same side interior angles. We had alternate exterior, which are switching sides of the transversal, and on the exterior, that would be 2 and 7 and 1 and 8. And then lastly, the only one that doesn't go with this naming protocol would have been these angles that we called corresponding angles. So for example, 1 and 5 are both in the top left. 2 and 6 are on the top right. 3 and 7 are in the bottom left. And 4 and 8 are in the bottom right. And those are going to be called corresponding angles. Now, while these are the names if the lines are parallel, it's also the names if the lines are not parallel. It just so happens that they just won't have any special characteristics. Now, we learned from the activity above that the angles are either going to be supplementary or congruent. So when you look at these, let's look at the alternate interior angles because these are parallel lines. 3 and 6 look to open up exactly the same amount, so those would be congruent. 4 and 5 would also be congruent. So alternate interior angles, when the lines are parallel, are congruent. When we look at the same side interior angles, they are not going to be congruent, so the only other option is they are supplementary. Alternate exterior angles and corresponding angles seem to open up exactly the same amount, so they are going to be congruent. So that is that. Now to summarize all this, the if-then statement, because it has to be a condition and a conclusion, the condition is the lines have to be parallel and cut by a transversal. And the conclusion would be corresponding angles, alternate interior angles, and alternate exterior angles are going to be congruent, and same side interior angles are going to be supplementary. Now, the easiest way to memorize this is just the one that has an S in it, same side interior, are the ones that are supplementary. Now let's take a look at number one. Number one is a little tricky because what it's doing is it's saying, tell me all the angles that have this characteristic with angle 30, but instead of just having two lines in a transversal, we have many lines where some of the lines could be the lines or they could be the transversal. So if you look at 30 and 19, 30 and 19 could be the interior between the middle and the bottom line, and they are switching sides of the transversal. So that would be alternate interior angles. 30 and 7 are also switching sides of a transversal, and they are between the top line and the bottom line. So those would be alternate interior angles. 30 and 36 are also switching sides of the new transversal, and they are between the middle line and the right line. So those ones would be alternate interior angles as well. So the key to this, which I'm not able to actually show, which I was able to do in class because I was able to cover up the rest of the lines, here what you have to do is pick two lines in a transversal and then figure out what the alternate interior angles, same side interior angles, or anything like that would be. For B, 30 and 20 are same side and on the interior, 30 and 8 are same side and on the interior, 30 and 33 are on the same side and on the interior. Now, when some people wanted to say 30 and 26 were on the same side and on the interior, but they are not. Because if you drew the left line and the middle line and made that bottom one the transversal, 30 is now on the exterior, not on the interior, so it cannot be a same side interior angle. So hopefully that's making sense. Now the corresponding angles, 30 is in the top right corner. So go to any intersection that is connected by a line to the intersection where 30 is, like 30 and 18, top right, 30 and 6, top right, 30 and 34, top right, and 30 and 26, top right. Now, why isn't it 30 and let's say 14? Because those aren't even connected by a line. 30 and 22, nope, those aren't connected by a line either. 30 and 10, not connected by a single line, so they are not two lines intersected by a transversal. Now the last one that we have here is alternate exterior angles with 30. 30 and 27 are the only one, 27 is the only thing that could be an alternate exterior angle with 30. And the reason why is 30 is on the interior between any other two lines except for the left one and the middle one. Then the left one and the middle one, 30, turns out to be on the exterior. So it'd be 30 and 27. Now, on here it says, which pairs of angles are supplementary? Now, this is a very open-ended question. You could have picked any angles that were linear pairs, because those are supplementary, or you could have found the same side interior angles, or, which we didn't talk about, but same side exterior angles are also going to be supplementary. Then it asked if angle 1 was 120, what would these other angles be? So you could be using linear pairs, you could use vertical angles, and you could use everything we learned today. Alternate interior angles, alternate exterior angles, corresponding angles, and SSIA. Now on number 4, it says find the value of x. On x, these are going to be alternate exterior angles. So alternate exterior angles have to be congruent, so we set them equal to one another. And when you set them equal to one another, you end up getting 12. The last one says a transversal is cuts two parallel lines so that the corresponding angles are supplementary. What must be true about the transversal? Well, we know corresponding angles are supposed to be congruent, not supplementary. So they have to be congruent. Is there any way congruent angles could also be supplementary? And the angle is yes, or the answer is yes, only if they were both right, which means that the transversal was perpendicular. Now let's go ahead and go through these. You had to find the alternate interior angles, same side interior angles, and corresponding angles with angle 20, 30, and 19. Once again, you pick any two lines and a different transversal that would have, let's say, 20 or 30 as part of it. So we already did actually the same side interior angles with 30. That was in the notes. So it's 30 and 20, 30 and 8, and 30 and 33. The alternate interior angles would be 30 and 21, 30 and 29. And then lastly, corresponding angles, since alternate interior angles was supposed to be with 20. So alternate interior angles with 20 would be 21 and 29, because that would be switching sides and on the interior between two lines. And the last one, corresponding angles with 19 would be 7, 31, 23, and 15. You have to pick two lines in a transversal that includes the intersection where that angle is and ignore everything else. Now, all of these ones are either going to be congruent or they're going to be supplementary. So you had to figure out, are they the type of angles that are congruent or supplementary? The only ones that are supplementary are going to be SSIAs. So A is not SSIA, so it's going to be congruent. Those are alternate exteriors. B is SSIAs, so you add them to 180. C is not SSIAs. They are corresponding angles. They are going to be congruent. And D is going to be, those are going to be congruent as well. All right, hopefully that made sense. So once you get it to either add to 180 or set them equal to one another, you can solve. And you can see how I did that for all those problems. Next one, use the word sometimes, always, or never to answer the following questions. Corresponding angles are always going to be congruent if parallel lines are cut by a transversal. SSIs are supposed to be supplementary, but when they are both 90, meaning they're supplementary, then they're also congruent. So that's sometimes. Alternate interior angles are going to be never complementary. And the reason why is that alternate interior angles are supposed to be congruent. And let me think on this one. Is it possible for alternate interior angles to be congruent and complementary? I would like to take my answer back on here. I'm going to make that sometimes. And the reason it's going to be sometimes is there is a possibility that the angle was cut so that the alternate interior angles are both 45 degrees. So that one is supposed to be sometimes, not never. Now on here, justify how you know the following statements are true, given parallel lines and cut by a transversal. 1 and 4 must be congruent because of the vertical angles theorem. They're vertical angles. 6 and 8 must be supplementary because linear pairs are supplementary. 3 and 6 are alternate interior angles. And 4 and 6 are SSIA. Okay, hopefully that made sense. The last one, it says Kendra is trying to remember which types of angles are congruent and which type are supplementary when two parallel lines are intersected by a transversal. She remembers that she can kind of just look at it and see if they're congruent or supplementary. She remembers the teacher told her that when in doubt, just draw two parallel lines in a transversal and look at them. Explain why her example of the parallel lines in transversal below was a poor choice in the goal of being able to figure out if they're congruent or supplementary. Well, when you have perpendicular line to the parallel lines, you end up with nothing but 90-degree angles. And 90-degree angles are going to be both supplementary and they're also going to be congruent. So that doesn't help anything. All right, thanks for watching.